We're going to work on Benson Brothers standard costing problem. Let's have a look and see what we've got. Benson Brothers makes hockey pucks for national teams. They're located in a very harsh climate. The last few winters have been very harsh, so many families have relocated, leaving them short of labor. They are tired of struggling with hiring local labor, so they've outsourced and asked somebody else to bring in their labor to assemble the pucks. Okay, so this is an experiment, and so after the first month of outsourcing the labor, of having the other firm provide their labor, here's how things turned out. So they made 100,000 pucks during the month, or the period. The standard for materials is a £1/4 per puck, and it should cost $2 for each pound of resin. And then the labor, it should take 0.15 hours to process the puck, and the direct labor, standard direct labor rate is $8. So, and then we have the actual results for the period: how much resin they bought, how much resin they used, what they spent on the resin purchased, how many labor hours they used, and how much they paid the labor. So let's do the 4 variances, the 2 material variances and the 2 labor variances. So let's start on the material price variance. We would compare what we paid to what we should have paid. All right, what did we pay? We paid $57,000 on resin. All right. So how much should we have paid? We should have paid $2 for each pound of resin we bought, and we bought 30,000 pounds. All right, so let's do that math. So we should have paid 60,000. We paid 57, so that's favorable. We just take the absolute value of these two numbers, by the way, and so that's favorable. And that's our material price variance. All right, what about material usage? This is comparing what we used to what we should have used. All right, so how many pounds did we use? 28,000. What should we have used? Well, we should have used 0.25 for each one of the pucks we made. Okay. All right, so we used 3,000 more pounds, absolute value of those two. And we don't leave it in pounds, we want to convert it to dollars so we know how serious the problem is. We can't tell from pounds. If pounds are cheap, it's not serious. If they're expensive, it's very serious. So we multiply it times the standard rate, and the standard rate is $2. And it's unfavorable. Okay, what about the labor rate variance? All right, so here we're going to compare what we paid to what we should have paid. Very similar to the price variance. Let's see, we paid $108,120. And what should we have paid? Well, we should have paid $8 for each hour worked. How many hours were there? 10,600. All right. So that's a big difference. Absolute value of those two numbers. Is it favorable or un? You paid more than what you should have, so that's unfavorable. All right, so they paid a lot more per hour. What about the labor efficiency? How long you took versus how long you should have took. All right, let's see, how many hours did it take them? It took them 10,600 hours. How many hours should it have taken them? Well, 0.15 times each puck. Well, they made 100,000 pucks. Okay, so they went a lot faster, didn't they? Because we thought it was going to take 15,000 hours. It took a lot less than that. How many hours difference? So that's in hours. We want it in dollars because we don't know how serious that is till we express it as a dollar. So that times, and the rate was $8. Okay, and that's favorable. So that's a great big favorable variance. And so then they ask, given that you've made these computations, how would you interpret these, or what else might you want to know? So let's interpret these now. So the savings on the material price was smaller than the unfavorable variance of using a little bit more material, but neither of those numbers are large compared to the labor rate variances. The labor rate variance, it looks like we paid a ton more than $8 an hour, and they made it really quickly. So is that a good trade-off or not? Perhaps we could have hired more capable workers and maybe they wouldn't have run off in the harsh weather. Who knows? But we really only have one period of data here, so we would probably want more than just one period of data. So they did it so fast, could they have left out some steps? Could we have a quality problem once this puck gets used in a game if it wasn't allowed to cure long enough? So the quality of the products is important. Could it be that we won't be able to keep these workers, that they won't stick around for a long time? So there's more to understanding whether this can be sustained. Sometimes there's a halo effect. The very first time you do it, everybody's watching you and you're not in your regular routine. You're on your very best behavior, kind of a honeymoon period. So you probably want more than one period worth of data. And also you want to be sure that the pucks hold up, especially since they made them so quickly. Maybe they didn't make them as carefully as the prior workers. So there you have it.